elimination reactions are also known as beta elimination, as well as it is known as what? Dehydrohalogenation. If I remove hydrogen from beta 2, CH3 become CH2, it will become pentone. The reagent which is used in dehydrohalogenation is alcoholic potassium hydroxide. These alkyl halides also reacts with what? Metals. When they reacts with metal, they'll form organometallic compounds. Hello everyone, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear students, last class, that is in the 4th session, I discussed about substitution nucleophilic unimolecular SN1 mechanism. Second one, I discussed about SN2 mechanism. Next, stereochemical aspects of both SN1 and SN2 mechanisms in alkyl halides. Last one, the order of reactivity. Last session, I discussed about SN1 and SN2 mechanism, stereochemical aspects of this SN1 and SN2 mechanism in alkyl halides, as well as what? Order of alkyl halides. Today, that is, in the 5th session of this same chapter, I am going to discuss about elimination reaction. Second one, reaction with metals. Third one, reactions of haloarenes. Elimination reaction, reaction with metals, as well as reactions of haloarenes. First one, let us consider elimination reactions. The very important reaction that is known as what? Elimination reaction. This elimination reaction is also called as dehydrohalogenation. It is also called as dehydrohalogenation. Dehydrohalogenation. And also it is called as beta elimination. It is also called as what? Beta elimination. Elimination reactions are also known as beta elimination, as well as it is known as what? Dehydrohalogenation. Why it is called as dehydrohalogenation? Dehydrohalogenation means dehydrohalogenation. Dehydrohalogenation means removal of hydrogen and halogen. Removal of hydrogen and halogen is called as what? Dehydrohalogenation. For example, what is dehydration? Removal of water. What is decarboxylation? Removal of carbon dioxide. What is dehydrogenation? Removal of hydrogen. Similarly, what is dehydrohalogenation? Dehydrohalogenation means removal of hydrogen and halogen. Removal of hydrogen and halogen is called as what? Dehydrohalogenation, as well as it is also called as elimination reaction, as well as it is also called as what? Beta elimination. Beta elimination. It can be done by heating. Haloalkane with beta hydrogen atom is heated with alcoholic potassium hydroxide. Heated with which one? Was the reagent here required? Alcoholic potassium hydroxide. Potassium hydroxide, if it is dissolved in alcohol, it is known as alcoholic potassium hydroxide. Therefore, alcoholic potassium hydroxide is called as dehydrohalogenating agent. Dehydrohalogenating agent. One mark, very important question. Name a dehydrohalogenating agent. Dehydrohalogenating agent is alcoholic potassium hydroxide. Alcoholic potassium hydroxide. Or one mark, very important question. Name a reagent which is used in dehydrohalogenation. The reagent which is used in dehydrohalogenation is alcoholic potassium hydroxide. Now I am going to consider a general formula of alkyl halide or CH2, X. Okay. Here, in case of alkyl halide or haloalkane, the functional group is X, capital X, where X is equal to halogen atom, chlorine, bromine, iodine, The carbon atom to which halogen atom is attached or to which functional group is attached, it is called as alpha carbon. It is called as what? Alpha carbon. And hydrogen atoms which are attached to alpha carbon, they are known as alpha hydrogen. They are known as alpha hydrogen. Once again, I'll repeat, my dear student, the carbon atom to which halogen atom or functional group is get attached, that carbon is called as alpha carbon. To alpha carbon, the number of hydrogen atoms which are attached, they are known as alpha hydrogen. Next carbon is called as beta carbon. The hydrogen atoms which are attached to the beta carbon, they are called as what? Beta hydrogen. For elimination or dehydrohalogenation, elimination or dehydrohalogenation, you have to consider haloalkane with beta hydrogen. Haloalkane which containing beta hydrogen. Was the condition for an alkyl halide to undergo elimination or dehydrohalogenation? Haloalkane must and should contain beta hydrogen. What is beta hydrogen? Hydrogen atoms which are attached to the beta carbon. What is beta carbon? Which is next to the alpha carbon. What is alpha carbon? To which the functional group is attached. Okay, let us take haloalkane with beta hydrogen atom heated with alcoholic solution of potassium hydroxide. Heated with alcoholic solution of what? Potassium hydroxide. What happens when it is heated with alcoholic solution of potassium hydroxide? There is an elimination of, now here you observe the skeleton, this is known as alpha carbon. Why it is called as alpha carbon? To which X is attached. Now this is called as beta carbon and this hydrogen is called as what? Beta hydrogen. Beta hydrogen. What happens when it is heated with alcoholic potassium hydroxide? There is an elimination of hydrogen atom from beta carbon and elimination of halogen from alpha carbon. My dear student, observe very carefully. You have to eliminate halogen atom from which carbon? Alpha carbon. Eliminate hydrogen from which carbon? Beta carbon. Therefore, I am removing hydrogen from beta carbon, halogen from alpha carbon. Therefore, I removed what? H and X. I removed what? H and X. I removed H, X, and so after removal, the single bond will become double bond. Single bond become double bond. Ali, what's the product formed during dehydrohalogenation? Dehydrohalogenation, there is a formation of alkene. There is a formation of alkene. What's the product formed during dehydrohalogenation or beta elimination? Alkene. Aliga, once again I'll repeat, what is elimination or beta elimination or dehydrohalogenation? Haloalkane which containing beta hydrogen. Haloalkane which containing beta hydrogen is heated with alcoholic solution of potassium hydroxide. There is a elimination of halogen from alpha carbon, hydrogen from beta carbon. To the resultant product is alkene. Alkene is formed. This reaction is also called as beta elimination. Also called as what? Beta elimination. Now let us consider propyl bromide. Propyl bromide, N-propyl bromide. Now, to this carbon, bromine atom is attached, therefore it is known as alpha. Next to alpha, it is known as what? Beta. When it is heated with alcoholic potassium hydroxide, you have to remove halogen from alpha carbon, and here how many beta hydrogen atoms are there? 2 beta hydrogen atoms are there. In that you remove 1 beta hydrogen. Therefore, it will become CH3, CH, CH2 become CH, CH2 become CH because I am eliminating 1 hydrogen, and here it become what? Double bond CH2. This K takes Br and KBr. OH takes H and it will form H2. What's the product form? Propene. The product formed is propene. Okay? When N-propyl bromide undergo dehydrohalogenation or elimination, it will form propene. I eliminated bromine from alpha carbon and hydrogen from beta carbon. Now, if more than 1 beta hydrogen atom is present, there is a formation of more than 1 alkene. During dehydrohalogenation, if there is more number of beta hydrogen atoms are present, there is a formation of more than one alkene. So first I'll explain the example, then we'll get to know how the product is formed. In some of the alkyl halides or haloalkane, they contain 2 or more beta carbon. Then it has more number of beta hydrogen. So during that reaction, there is a formation of more than one alkene. There is a formation of more than one alkene. For example, I'll consider 1, 2, 3, 4, 5. If I number like this, what's the IUPAC name? It is 2-bromopentane. It is 2-bromopentane. If I am going to heat this with alcoholic potassium hydroxide, the carbon atom to which bromine is attached, it is known as alpha carbon. So now it is known as beta 1 and it is known as what? Beta 2. There are how many beta carbon? 2 beta carbon. What I told, there is a next to the alpha carbon, it is what? Beta carbon. Let us consider this as alpha carbon. Why it is called as alpha carbon? To which halogen atom is attached. Now it is known as beta 1, now it is known as beta 2. In the first case, I will remove hydrogen from beta 1. When I remove hydrogen from beta 1, it will become CH double bond CH. The product is pent-2-ene. Product is pent-2-ene. If I remove hydrogen from beta 2, CH3 become CH2. It will become pent-1-ene. Pent-1-ene. Therefore, here there is a formation of how many alkenes? 2 alkenes. Pent-2-ene and pent-1-ene. When there is a formation of 2 or more products, we have to find out which is major and which is minor. It can be determined by using one rule. That rule is known as Saytzeff rule. Which rule it is known as? Saytzeff rule. According to this rule, during dehydrohalogenation, if there is a formation of more than 2 alkene or more than 2 alkene, the major alkene is the one which containing more number of alkyl group, number of alkyl group which is attached to carbon-carbon double bond, Now observe, my dear student, in pen-2-ene, carbon-carbon double bond is attached with 2 alkyl group. One is methyl, another one is ethyl, another one is what? Ethyl. But here the carbon-carbon double bond is attached with 1 alkyl group, that is only propyl. Here it is attached with hydrogen. It is not alkyl group. It is not alkyl group. Therefore, pent-1-ene is attached with only 1 alkyl, that is propyl. Pent-2-ene is attached with 2 alkyl group. One is ethyl, another one is methyl. Which is major product here? Pent-2-ene. Therefore, during dehydrohalogenation, if there is a formation of 2 alkene, which is considered to be as major product, the major product is one where it contains more number of alkyl group which is attached to the double bonded carbon atom. This rule is called as Saytzeff rule. What's the statement of Saytzeff rule? In dehydrohalogenation reaction, the preferred product is that alkene which has the greatest number of alkyl groups attached to the doubly bonded carbon atom, So from according to this rule, which is here major? Pen-2-ene is major. Why pen-2-ene is major? Because it is attached with how many alkyl group? 2 alkyl group. Here it is called as minor because it is attached with only 1 alkyl group. So this is about what? Which rule? Saytzeff rule. And about dehydrohalogenation. Dehydrohalogenation is also called as beta elimination. Was the reagent required for beta elimination? So alcoholic potassium hydroxide. Was the product formed during dehydrohalogenation? Alkene. Next reaction. Reaction with metal. These alkyl halides also reacts with what? Metals. When they react with metal, they'll form organometallic compounds. Why they are called as organometallic compound? There is a formation of carbon-metal bond. There is a formation of which one? Carbon-metal bond. If there is a formation of carbon-metal bond, they are known as organometallic compounds. Therefore, organohalogen compound reacts with metal to form organometallic compounds. Now, here So alkyl halides or organohalogen compound reacts with magnesium. They'll form in the presence of dry ether. In the presence of what? Dry ether. They'll form organomagnesium halide. They'll form organomagnesium halide. Here which metal I have considered? Magnesium. And which one is used as solvent? Dry ether. So when organohalogen compounds heated with magnesium in the presence of dry ether, they'll form organomagnesium halide. These organomagnesium halides are also called as Grignard reagent. Also called as what? Grignard reagent. What's the other name of organomagnesium halides? Organomagnesium halides are also called as Grignard reagent, and they are represented by general formula RMgX. Therefore, 1 mark, very important question. What are Grignard reagents? What are Grignard reagents? Grignard reagents are organomagnesium halides. Grignard reagents are organomagnesium halides. What's the general formula of Grignard reagent? RMgX. Where here, in case of Grignard reagent, R not only alkyl group, it may be aryl group, alkenyl group, or allyl group. Okay, what is R? R may be alkyl, R may be aryl, R may be alkenyl, R may be allyl. And X, as usual, it is an halogen atom: chlorine, bromine, iodine. Therefore, organic compounds, that is organohalogen compounds, that is haloalkanes and haloarenes, they reacts with metal. What happens when they reacts with metal? They'll form carbon metal bond. Therefore, they are known as organometallic compound. What happens when they heated with magnesium? In the presence of dry ether, they'll form organomagnesium halide. They'll form organomagnesium halide. This organomagnesium halides are also called as what? Grignard reagent, and the reaction is called as, Grignard reaction. And this reaction is called as what? Grignard reaction. It's a very important question for your board. Okay, explain Grignard reaction. Rx plus Mg in the presence of dry ether, it gives rise to RMgX, where R not only alkyl, here it is alkyl, aryl, alkenyl, as well as what? Allyl group. Let us consider example for Grignard reaction. So, Rx plus Mg in the presence of dry ether give rise to RMgX. It is known as Grignard reagent. So, let us consider in place of R, you take ethyl. What's the formula of ethyl? CH3CH2. It is ethyl bromide. IUPAC name is bromoethane. Introduce this magnesium in between ethyl and bromine atom. It will give rise to CH3CH2MgBr. CH3CH2MgBr. Magnesium is introduced between R and X. It is Rx. In between R and X, you introduce magnesium. So, therefore, it will become, here it is CH3CH2Br. Here it will become what? CH3CH2MgBr. Therefore, the two reactants become one product. Therefore, Grignard reaction is also an example for addition reaction. It is an example for addition reaction or combination reaction. Two reactant, it will form what? One product. So, Grignard reagent. Here, in case of Grignard reagent, please listen carefully, my dear student. Why you have to use dry ether only? Why can't you use other solvents? Like, as you know, there are so many very important solvents in reaction, that is water, alcohol, amines, because they contain active hydrogen. If you use water, amines, alcohol, acid, they contain which type of hydrogen? They contain active hydrogen. What happens if you use the solvent which containing active hydrogen? This Grignard reagent reacts with this active hydrogen, and they'll form hydrocarbon. Instead of Grignard reagent, you are going to get hydrocarbon. hydrocarbon. Therefore, compounds containing active hydrogen are not used as solvent in the preparation of Grignard reagent. Therefore, the solvent like dry ether is preferred. Why you have to use dry ether? If you use other solvents like water, alcohol, acid, amines, they contain which type of hydrogen? It contains active hydrogen. This active hydrogen reacts with a Grignard reagent and it will form hydrocarbon. Due to that reason, we have to use dry ether. 1 mark, very important question. Name a solvent which is used in Grignard reaction, that is dry ether. Once again, I will repeat. What is Grignard reagent? Organomagnesium halide. Organomagnesium halide is called as Grignard reagent. The general formula is RMgX. R not only alkyl, it is alkyl, aryl, allyl, etc. Okay, X is halogen atom. The preferred solvent is dry ether because other solvents like water, acids, amine, they contain active hydrogen. If it reacts with Grignard reagent, and they will form what? Hydrocarbon. Second reaction with metal. First, I finished with what? Magnesium. If it reacts with magnesium, it reacts called as what? Grignard reaction. It is called as what? Grignard reaction. Reaction with what? Metallic sodium. Here also solvent is dry ether. The solvent is what? Dry ether. So when alkyl halide, 2 molecules of alkyl halide. What's the molecularity of this reaction? 2. Instead of I'll show how to remove that, I'll write 1 molecule of alkyl halide, 1 molecule of alkyl halide from this plus 2Na plus 2Na. It is easy to eliminate 2NaX. Therefore, it will become what? R plus 2NaX. So, what's the product from? Alkane. What's the product from? Alkane. If here 1 R, it will become what? Double R. Therefore, the product alkane has root word is double than the reactant. Double than the reactant. For example, if I take ethyl bromide here, if I take ethyl bromide plus 2Na, one more you write 1 molecule of ethyl bromide. Ethyl bromide. Here 1 molecule of ethyl bromide. Here also 1 molecule. Remove 2NaBr. 2NaBr in the presence of dry ether. In the presence of what? Dry ether. In the presence of solvent what? Dry ether. It will form CH3, CH2, CH2, CH3, CH3 plus 2NaBr. Plus 2NaBr. It is N-butane. N-butane. Here the root word is the compound is ethyl bromide. Ethyl bromide. Root word is eth. Root word is eth. So when eth is there, the root word will become but. When eth, it will double but. When propyl was the alkane from double and hexane. When you use butyl, the double, it will become octane. When you use pentyl, it will become double, it will become decade. Like what is Wurtz reaction? When alkyl halides are heated with metallic sodium in the presence of dry ether, it will give rise to alkane. Formula Rx plus 2Na plus Rx give rise to Rr plus 2NaX. Rr plus 2NaX. In place of R, you put ethyl. What is ethyl? CH3, CH2. We'll get N-butane. You'll get N-butane. Next, haloarenes. How these haloarenes are prepared? The preparation of haloarene. Haloarenes are prepared by the electrophilic substitution reaction. Electrophilic substitution reaction is the characteristic reaction of aromatic hydrocarbon. Characteristic reaction of aromatic hydrocarbon. By electrophilic substitution, how can you prepare aryl chlorides as well as aryl bromide? Can be easily prepared by electrophilic substitution of arenes. Arenes is in the introduction class also explained that they are aromatic hydrocarbons. They are aromatic hydrocarbon. What are aromatic hydrocarbon? Which containing at least one benzene ring. Okay. So, how can you prepare haloarenes? The first method of preparation by electrophilic substitution. Already you know about nucleophilic substitution. Now, I am going to explain about electrophilic substitution. Electrophilic substitutions of arenes. Arenes means aromatic hydrocarbon. From this, one we can prepare alkyl chlorides as well as what? Alkyl bromides. And how we can prepare chlorides and bromine? By heating with chlorine and bromine in the presence of Lewis acid catalyst like iron or ferric chloride or iron 3 chloride, ferric chloride or iron 3 chloride. I'll take 2 molecules of toluene. You know, toluene is trivial name, IUPAC name is methyl benzene. When it is heated with 2 molecules of halogen, 2 molecules of halogen, where X is either Cl or bromine. Halogen, either you take chlorine or bromine. One halogen atom goes to ortho position, one more goes to para position, Therefore, we'll get 2 products. One is, we'll get a mixture of 2 isomers. One is ortho, another one is para. Ortho and para products are formed. Ortho and para. This is ortho and this is para. Okay. When you consider this as a benzene ring, if it is a substituent or functional group is present, this is ortho, this is meta, and this is para. It is para. Ortho, meta, para, and it also meta, and it is also what? Ortho. Therefore, here we get how many isomer? One is ortho, another one is para. There is no question of formation of meta isomer. What's the catalyst used here? Iron or iron 3 chloride or iron 3 bromide. If you use chlorine, you use iron 3 chloride. If you use bromine, use iron 3 bromide, or iron as a what? Catalyst. You will get a mixture of ortho and para isomer. Ortho and para isomers are easily separated due to large difference in their melting point. Under physical properties of haloarenes, I already discussed that para isomers having high melting point than ortho and meta because of its plane of symmetry. The molecules are tightly packed in crystal lattice. Therefore, compared to 3 isomers, ortho, meta, para, which has high melting point, para has high melting point. Actually, para isomer has 70 to 100 degrees centigrade melting point is more than that of ortho. When there is a large difference between the melting point of ortho as well as what? Para, they can be easily separated. Next, very compulsory as well as very, very important question for your board. Sandmeyer's reaction. So, what is this Sandmeyer reaction? Consider primary aromatic amine. Aromatic means it containing benzene in primary amine whose functional group is NH2. NH2 is a functional group of primary amine. If this NH2 group is attached to benzene ring, it is aromatic primary amine, and its trivial name is aniline. It is known as what? Aniline. Treated with sodium nitrite and cold aqueous mineral acid, that is HX. HX is either HCl, HBr. Okay. So, when an aromatic primary amine dissolved or suspended in cold aqueous mineral acid treated with sodium nitrite, diazonium salt is formed. Diazone. What's the temperature required here? 273 to 278 Kelvin or 0 degree centigrade to 5 degree centigrade. We're going to get benzene diazonium halide. Is formed. This benzene diazonium halide is heated with cuprous chloride or cuprous bromide. Where X is equal to chlorine or bromine. When it is heated with cuprous chloride or cuprous bromide, the replacement of benzene diazonium group by chlorine or bromine. Either you are going to get chlorobenzene or what? Bromobenzene. Once again, I'll repeat. When a primary aromatic amine is dissolved in cold aqueous mineral acid and sodium nitrite, NaNO2, at 0 to 5 degree centigrade or 273 to 278 Kelvin, there is a formation of benzene diazonium halide. This benzene diazonium halide heated with cuprous chloride or cuprous bromide, you are going to get chlorobenzene or what? Bromobenzene. If you want iodobenzene, it cannot be possible in the presence of cuprous iodide. It is not possible in the presence of what? Cuprous iodide. If you want to convert benzene diazonium halide to iodobenzene, to iodobenzene, it can be done by heating with potassium iodide. It can be done by heating with what? Potassium iodide. How can you prepare chlorobenzene and bromobenzene? Chlorobenzene and bromobenzene is prepared by treating benzene diazonium halide. Benzene diazonium halide with cuprous chloride or cuprous bromide. Okay. But iodobenzene cannot be obtained by heating benzene diazonium halide with cuprous iodide. It can be obtained by heating with potassium iodide. Heating with potassium iodide. And the very important thing is, in Sandmeyer's, the temperature required is 0 degree to 5 degree centigrade. 0 degree to 5 degree centigrade. Okay. Now, when you consider the nucleophilic substitution reaction, both haloalkane and haloarene, that is alkyl halides and aryl halides, both undergo nucleophilic substitution. But in case of aryl halides, the aryl halides are less reactive towards nucleophilic substitution reactions. When you consider aryl halides and alkyl halides, which are less reactive, aryl halides are less reactive. Alkyl halides are more reactive. It can be explained by using following reason. First one, due to resonance. Let us consider chlorobenzene. Chlorobenzene. Chlorobenzene is an example for aryl halide. Carbon-chlorine bond in chlorobenzene has partial double bond character. It has partial double bond character. It has partial double bond character due to resonance. Here on the board, you are observing how many resonance structures I had written for chlorobenzene. 5 resonance structures. Chlorobenzene undergo resonance. Because of resonance, carbon-chlorine bond acquires partial double bond character. When the double bond length is 169 picometer, but C-chlorine, carbon-chlorine single bond has bond length 177 picometer. In alkyl halide, carbon-chlorine bond length is 177 picometer. That is in alkyl chlorides, as well as in aryl chlorides. In aryl chloride, carbon-chlorine double bond, it has 169 picometer. As a result, the bond cleavage in haloarene is difficult compared to haloalkane, since it is difficult to break shorter bond than larger bond. When bond is larger, it is easy to break. When bond is shorter, it is very difficult to break. Earlier class I explained bond length and bond strength are inversely proportional. As bond length is more, it is easy to break. Here, which one has shorter bond length? Carbon-chlorine double bond has shorter bond length. Its bond length is 169 picometer, as well as carbon-chlorine single bond has 177 picometer. Therefore, hence aryl halides are less reactive towards nucleophilic substitution reaction. Aryl halides are less reactive towards nucleophilic substitution reaction. One more reason, difference in hybridization of carbon atom. Difference in hybridization of carbon atom. When you consider aryl halide, X is attached to sp2 hybridized carbon. Here, X is attached to sp3 hybridized carbon. Why it is called as sp2 hybridized carbon? It is attached with double bond. sp3 hybridized carbon, it is attached with single bond. sp3 hybridized carbon atom. So now, sp2 hybridized carbon atom has S character is more. Here, the S character is 33.3%. Here it is 25%. As S character is more, the electron negativity also more. Therefore, it is very difficult to detach X from carbon. Last one, high electron density on benzene. Because of the possible repulsion, it is less likely for the rich nucleophile to approach electron-rich arenes. Okay. Next, replacement by hydroxyl group. How do you convert? It is chlorobenzene. Chlorobenzene. How can you convert chlorobenzene into phenol? It is phenol. If chlorine atom is replaced by OH, it is nothing, it will become what? Phenol. How do you convert chlorobenzene into phenol? Andre, when chlorobenzene is heated with aqueous sodium hydroxide at 623 Kelvin and 300 atmospheric pressure. What are the conditions? 623 Kelvin and 300 atmospheric pressure. Sodium phenate is formed, which on acidification gives phenol, and this reaction is called as Dow's process. This process is called as what? Dow's process. What is Dow's process? Conversion of chlorobenzene into phenol. Conversion of chlorobenzene into phenol is called as Dow's process. How do you convert chlorobenzene into phenol? Chlorobenzene can be converted into phenol by heating chlorobenzene with aqueous sodium hydroxide at 623 Kelvin and 300 atmospheric pressure, and followed by acidification will get phenol, and it is a commercial method of production of phenol. Commercially, how phenol is produced? Commercially, phenol is produced by using one method. That process is called as what? Dow's process. Your process of Dow's process. Next, that is electrophilic substitution or nucleophilic substitution. The presence of an electron withdrawing group NO2 at ortho and para position increases the reactivity of haloarenes towards nucleophilic substitution reaction. Towards nucleophilic substitution reaction, if you want to increase the reactivity of haloarene, introduce electron withdrawing group. Okay, as you know that substituent. In substituents, there are two types of substituent: electron withdrawing group as well as electron releasing group. Electron withdrawing groups as well as what? Electron releasing group. Electron withdrawing groups are NO2, Cn, and all halogen: chlorine, bromine, iodine, OCH3, OH, and C6H5, all are called as electron withdrawing group. Now consider electron withdrawing group NO2 at which position? Ortho. Which position? Ortho and para. Ortho and para. Ortho and para. First, I'll introduce NO2 at only ortho position. What's the temperature required? 443. What's the temperature required? 440. I'll introduce NO2 in both ortho and para. The temperature decreases to 368. Observe my student. Only at ortho, NO2 at ortho, what's the temperature? 443. Ortho and para, it is 368. Ortho, para, and once again ortho, just warm. So observe, by introducing electron withdrawing group NO2 at ortho and para position, the temperature decreases. Temperature decreases means its activity increases. Therefore, in haloarenes, how can you increase the activity of haloarenes towards nucleophilic substitution reaction? Please, my dear student, introduce electron withdrawing group. EWG, like NO2 to which position? Ortho and para position. But this is not possible observed in which position? Meta position. In which position? Meta position. Only in which position? Ortho and para, not in meta. Only introduce EWG, electron withdrawing groups, in which position? Ortho and para, not in meta position. In this class, I discussed about elimination reaction as well as the methods of preparation of haloarenes and reactivity of haloarenes as well as what? Haloalkanes. How haloarenes are less reactive than haloalkanes towards nucleophilic substitution. Okay. Next session, I'll come up with what are the uses of polyhalogen compounds as well as reactions of what? Haloarenes. Thank you. Goodbye.